All right, welcome back. We're at Big Idea 3. We're going to look at a stoichiometry problem or two and see how well you guys can do it. This is going to be kind of more in the AP chemistry zone for stoichiometry, but very helpful even if you're not in AP chemistry and trying to study stoichiometry. All right, so kind of the things that you need to look out for is first of all is your equation balance. So let's go ahead and let's go back to that same equation that we balanced before. So let's say we've got aqueous hydrobromic acid, and we've got solid zinc, right? What's that going to turn into? Well, the zinc is going to combine with the bromine, and that is going to leave us with hydrogen gas. Okay, so here's our equation, and remember to balance this we had to put a 2 in front of here so that we end up with 2 bromines on both sides and 2 hydrogen on both sides. So once you're sure that everything is balanced and ready to go, then you can start your stoichiometry. Now these little things down here tell us the states of matter. So this is aqueous, so that's telling us that these things are dissolved in solution, separated into their ions. This is solid, so this is just going to be in solid chunks. Zinc bromide is also aqueous, and hydrogen is going to be a gas state, so that's going to bubble out in this reaction. So this reaction definitely going to produce bubbles, which is going to be the hydrogen gas. And so when it's all said and done, your zinc should be all dissolved or basically ionized. So there's some oxidation reduction going on in here as well. So we'll talk about that sort of thing later. But let's say that we had some. Let's say that we had some bits to this. Let's say that our zinc weighed 98 grams, and so let's say this is the information you're given. And let's say that we put in 324 grams of hydrobromic acid. So the question might be, what is the volume of hydrogen produced? So if I put in this mass and this mass, could I tell what the volume of hydrogen that is produced? Okay, so step one with solving stoichiometry problems is, first of all, if you're given masses or whatever information you're given about each element or compound, go ahead and stick it underneath that element. That's what I do. So write out the equation, put your information that goes with that element. And then the first thing that you're always going to want to do is, if these are masses, you need to convert them to moles. So converting to moles is your first step. So if we're going to talk about steps here, convert to moles. Just automatically do that. Don't even think. Just convert to moles. Just convert to moles. All right? So 320. So in order to convert to moles, you have to divide by the molar mass of things. So zinc's an easy one. Just look up on the table. 65.4 grams per mole. Right. So if I divide that out, I find out that zinc has 1.5 moles. And why do we convert to moles? Let's kind of remember that. Well, the reason is because each of these things weighs a different amount. But once we've converted to moles, we've got that every amount to a number which is based on off the number 6.02 times 10 to the 23rd. So then essentially what that does is it brings everything to the same playing field. If they all weigh different amounts, it's hard to tell, well, how much of this do I have and how much of this do I have? Because 324 grams of this means a whole lot different than 98 grams of this. But 1.5 moles of this and 1.5 moles of this is the same exact number of molecules or atoms. And so that brings it to an equal playing field. And so to get it equal, we divide by the molar masses of each one. And so then that factors in their different weights and then gets them on the same playing field. So for HBr, you're going to have to add 1 hydrogen plus 1 bromine. Now that's going to come out to 80.9 grams per mole. All right, so that's going to give us 4.0 moles. All right, so now we know the moles of this and we know the moles of this going in. So then the next thing you're going to have to do is you're going to have to look at this and you're going to have to figure out, okay, so what is my do I have excess? Do I have limiting and excess? So whenever you're given values for both reactants, and so you see that's what happened here. We had zinc and hydrobromic acid. And so we've been given values for both reactants. And so what you have to do is you have to analyze that and look at the mole ratio. So the mole ratios is 2 to 1. And I have to stay with that mole ratio, which means that I can't exceed it. So if I have a 2 to 1 ratio, if this is 1.5, the best I can do over here is 3.0 moles, you see. So what does that mean? Well, that means that I'm going to have 1 mole excess over here. Because this can only be a 2 to 1 ratio. These coefficients in front, and we don't have a number here, but it's 1, obviously. And so these coefficients are ratios of moles, and you cannot exceed them or go under them. You have to match them perfectly. So we have 1.5 and 3, so that's exactly 2 to 1. So 4 isn't going to work, because what's going to end up happening, as soon as I use 3 moles of this, I'm going to use up all of this. And once all of this is gone, the reaction stops, leaving a mole excess over here. Okay, so that's kind of your second step is look for excess or limiting situation. Limiting reactant situation. Now, you would not have a limiting and excess situation unless you are given values for each of the reactants, you see. So sometimes they'll say in excess sink or excess. So you'll know that there's excess, but they won't give you an amount, and so you just calculate it as if it was perfect. So anyway, so now the question is, so if we have 1 mole here, 1.5 moles, how many moles of hydrogen gas do we have? Well, we have 1 mole of hydrogen gas, right? I'm sorry. We're going to have 1.5 moles of hydrogen gas. And how did I know that? Well, this is the same ratio applies all the way across. So I have 2 to 1 to 1 to 1, which means that I'm going to have 1.5 moles of this as well. So this is double, and each of these are 1. So all of these are going to assume the 1 mole ratio, or 1 to 2 aspect of it. So this is going to be 1.5, just like this is, because it has the 1 in front of it as well. If it had a 2 in front of it, it would be 3. Okay? So now what do I do with this? Because I need to figure out volume of gas right here. Well, one bit of information that I'm going to need to know is either what is the temperature and pressure of this situation, or is this at STP? And let's say that this was at STP. Let's say they told us that this was at STP. STP is standard temperature pressure, and that equals 0 degrees Celsius and 1 atm. Okay? So at STP, though, the nice thing is that at STP, 1 mole of any gas equals 22.4 liters. So all I have to do is multiply this times 22.4 liters, and I'm going to get 33.6 liters. So that's, let's see, H2. So 33.6 liters of H2 gas is what's produced in this reaction. That was an easier one. If it wasn't at STP, of course, they'd have to give you the temperature and pressure. But if they give you STP, they essentially are giving you the temperature and pressure. So, we could also go ahead and we could figure out, some other information, like we could figure out how much zinc bromide was created in this process. That would be an easy one to do as well. So anyway, stoichiometry is just based off the conservation of mass idea that says that if I put in this amount, I know exactly how much I'll get out the other side, because mass is always conserved. If I put in this amount, I know exactly how much I get out the other side. And so you can use whatever knowledge you have of this. See, if you know exactly how much this went in on this side, well, then you'll know exactly how much came over here on this side. And the coefficients in front are our mole ratio. So we always convert to moles first, And then we can use the balanced equation to figure out the amounts for everything else. Now the limiting in excess sometimes throws a curveball in there, but all you have to do is just look for that. You got two reactants, look at the mole ratios, match them up, and make sure that you don't exceed. Because you wouldn't say, oh, I have 4 here, so now I need more than 1.5. But no, 1.5 is all you had. So this one is a limiting. All right. So hope that helps. Just a quick little stoichiometry review for you.